Greetings and welcome to lecture number 14 on unit number 5, part 2, external flow. This session we are going to discuss the numerical on drag and lift forces. The previous session we have discussed the theory part of drag and lift forces. There are only two expressions associated with drag and lift, the FD and FL expression in terms of CD 1/2 rho used A U square and CL 1/2 rho A use square. So straightway we solve the numericals. A truck having a projected area of 6.5 meters square, uh, are traveling at a speed of 70 kilometers per hour, has a total resistance of 2000 Newton. Of this, 20% is due to rolling friction, 10% due to surface friction. The rest is due to form drag. Make calculation for coefficient of form drag. Take rho is equal to 1.22 kg per meter for air. So projected area is given, that is 6.5 meters square. Truck is moving at a speed of 70 kilometer per hour. So that we convert it into meter per second, that is 19.44 meter per second. Density is given and the total resistance. So when the truck is traveling, it mainly experiences the form drag, which act on the frontal area, then the skin friction drag, which acts on the side areas parallel, or the surface which is parallel to the velocity of the air, then rolling drag. Okay, so these are the forces acting. So out of total, so if we see the resistance due to rolling drag, that is rolling friction, 20% is given. 20% of this is 400 Newton. Then resistance due to surface drag is 10% of the total, that is 200. And resistance due to form drag. So remaining is a form drag, that is 2000 minus 400 minus 200, that is 1400. So this is FD actually. Form drag is FD. So we have FD is equal to CDA 1/2 rho U square. So we have to calculate the coefficient of form drag. So we know FD, we know area, that is projected area is given, that is 6.5 meters square. Then density of the air 1.22 and the velocity is 19.44. So only unknown in this equation is CD. So by putting all the values, we can obtain the value of CD. So CD has no unit, so it comes around 0.934 Newton. So this is first example. Then second, assuming the cross-sectional area of the passenger car to be 2.7 meters square with a drag coefficient of 0.6. Estimate the energy requirement at a speed of 60 kilometer per hour. Assume the weight of the car is 10 kilonewton and the coefficient of friction is also given. This 0.012. This we can say as a part of rolling drag as well. Assume the density of the air is 1.208 kg per meter. So the given quantities we write in appropriate unit. Area, CD value. The speed of the passenger car is 60. So we convert into meter per second. The weight of the car is 10 kilonewton. And coefficient of friction, that is 0.012, which is given. The density is 1.2. So the car experiences, in this case, coefficient of friction here. It experiences drag. The skin friction drag is not given in this case. So the total energy requirement, the total resistance offered by a car, that is equal to aerodynamic drag force plus friction at the road surface. So aerodynamic drag force, it's a form drag, CDA 1/2 rho U square. plus mu into W. That is the friction coefficient or friction drag. That is a rolling friction, we can say, uh, is based on the coefficient of viscosity. Sorry, coefficient of this is friction coefficient mu into W. Now we have CD, we have A value, rho density is given, velocity is given. So we know this entire term. And weight of the car is also given. This calculated total resisting force is around 391.9 Newton. And the power is nothing but force into velocity. Now by putting the value of force and velocity, so you can calculate power. So you can imagine how much power is consumed for this passenger car. It is comparatively maybe a XU vehicle because the weight of the car generally it is around 150 kg, so 1000 Newton. So it is comparatively high. So the power requirement is also high. That is the power required to overcome the frictional or resistance offered or resistance experienced by the car. 6.50. So this way we can calculate because these calculations are essential for uh, deciding the engine power. So not only weight but also air resistance is also important. So this is the total power required for the engine to uh, uh, carry the weight as well as aerodynamic forces. And the next numerical, the vertical component of landing speed of parachute is 6 meter per second. Treat the parachute as an open hemisphere as shown in figure and determine its diameter. If the total weight of the weight to be carried is 1200 Newton, take density as 1.208 kg per meter. CD value is also given 1.30. So speed of the parachute, weight of the parachute, then density and drag coefficient is given. Now in this case, as the parachute is a flying object, means there is lift, but it is if it is coming down, then it experiences mainly a drag force. So diameter of the parachute, we can while calculating this is coming down, so it offers the component of this force is acting, which reduces the motion of this parachute. So this is coming down, so it experiences a drag force here, not a lift force. The projected area of the hemisphere of parachute is nothing but if we take its projection on it becomes a circle. This area of the by 4D square. This we have to calculate actually the area. Uh, we know FD is equal to, so it explains the drag force. So CD value for the drag force is also given. It's A half rho V square. So CD known to us, area is unknown. So instead of area, we can put pi by 4 D square and half rho V square. So density is given, speed is given. So we can calculate the diameter. So this way, this theory is also used for designing of parachute. So this is a drag force which is given actually as weight. Same equal and opposite force is the drag force. So putting all the values, we get diameter is 7.7 meters. So this is example of flying object. But in this case, if it is not a symmetric body, then it is always a drag force. This is not a symmetric body. As it is asymmetric, then it experiences a lift force as well. So like this, in the next example, we'll discuss the kite weighing 9.8 Newton and having an area of 1 meter square, makes an angle 7 degree to the horizontal when flying in a wind of 36 kilometer per hour. If pull on string attached to the kite is 49 Newton, that is a tension, and it is inclined to the horizontal 45 degree. Calculate the lift and drag coefficients. Density of the air is given, that is 1.2 kg per meter cube. Weight of the kite is given, that is 9.8 Newton. So this is a diagrammatic representation of the kite. Its weight is 9.8 Newton. And it makes angle, this is a kite, it makes angle 7 degree with the horizontal. And it is moving with when the wind is flying, where the wind velocity is given, that is 36. So this is asymmetric body. So here both lift and drag forces exerts. Lift force perpendicular direction of motion and drag force parallel to the direction of motion. If the pull on the string attached to the kite, if it makes 40 degree with the horizontal, this is 40 degree with the horizontal, and this pull is there, that is 49 Newton, and it is inclined 45 degree with the horizontal. Calculate the lift. So if you calculate the components now, this pull has this is a resultant force. It makes angle 45 with the horizontal. It has horizontal component in opposite direction of the wind, that is P cos theta. Vertical component, because the resultant force is downward, P sin theta. Similarly, weight, yes, it is vertical only. That is equal to 9.8. So drag force, equal and opposite. So there is only one component for drag force. So we have Fd, that is equal to force exerted by wind on kite in the direction of motion, that is in x direction forces. So all x direction forces, so Fd is equal to P cos theta, cos 45. So drag force is that. Then use the expression of Fd for calculation of the drag force. Is equal to CD A 1/2 rho u square. So area, projected area is given, that is 1 meter square. Density is given, 1.2 kg per meter. And velocity is also given, which is 10 meter per second. So coefficient of drag is calculated, which is asked. Lift coefficient. Now lift for coefficient, the vertical components. All vertical components are the lift components. So lift coefficient CL, that is equal to force exerted by wind on a kite perpendicular to the direction of motion. That is along y direction. So all these components, that is one weight as well as the y component of, so component of V in vertical downward direction, P sin 45 plus weight 9.8. So that comes around 44.45 Newton. So according to the expression of FL, okay, unknown again in this equation is here. All the relevant quantities we can calculate here. So in this we have covered almost all type of examples. At the end of this particular session, you will be able to calculate different types of drag forces, that is resistance for road vehicles, and also will be able to calculate both drag and lift forces for any flying objects like kite we have discussed. In case of parachute, even though it is a flying object, but it is a symmetric object. That's why if the object is symmetry and along the perpendicular directions, then it experiences only a drag force, not lift force. So lift force only generates for asymmetric objects. And wherever there is a lift force, drag force has to be there. But for drag force, it is possible to generate without lift force. So this theory you can apply for any submerged objects for calculation of track or look forces or resulting force. With this, we have completed this session.